Hi, I'm Doc Palmer. I'm the author of McGraw-Hill's best-selling reliability book, the Maintenance Planning and Scheduling Handbook. Maintenance planning and scheduling is a best practice. It's a bit hard to master because instead of doing perfect job plans, we want to run a Deming cycle, making plans better over the years. And scheduling, also included in that, is a bit tricky. Instead of making a calendar, we're trying to complete the schedule. Actually, we're trying to fully load schedules to defeat Parkinson's law. We've talked about that in the past. What we're going to do today and the next two sessions, we're going to fit maintenance planning and scheduling in its proper context. We're going to look at overall maintenance strategy and organizational clarity. Maintenance strategy begins with looking at what kind of maintenance we want to do. Mostly we're looking at work orders. These are coming out of our history. If you don't have that great a history, or even if you do have great history, we want to include your supervisors and some of your key craftspersons. We also want to work with operators to see what's going on with them. There are formal methods of looking at that. One of the most popular and one of the most effective over the past few decades is RCM, Reliability Centered Maintenance. There are different books on this. I'm not the expert on that. Nancy Reagan is one of the industry experts, not the president's wife. Nancy, and then Reagan spelled R-E-G-A-N. There's also what they call PM optimization, where you look at what you're doing with the PMs. There's also criticality analysis, looking at what you're doing with your most critical assets and identifying those. And just bad actors analysis, looking at where you're spending your most money, whether it's a formal or informal process. What we're trying to do with this is look at what kind of maintenance we'll be doing. First kind, they're not any particular order, would be engineering. Engineering is writing work orders or developing projects. It could be in-house or with contractors. They're doing root cause analysis to see where your biggest problems are, and they're trying to look at an engineering fix to replace or modify inherently reliable equipment. Then all the way at the other end, there's preventive maintenance. That's a type of maintenance. We'll also just list these: predictive maintenance and operators doing maintenance. The preventive maintenance is the low technology. It's the routine servicing. You're using your sight, hearing, smell, touch, perhaps taste. See what's going on with equipment. You might be measuring chain thickness at a certain intervals. It could be time-based intervals, every month, every week, every year, or it could be a certain number of miles, kilometers, hours of operation, or something like that when you do certain things. And it could be not just looking for conditions you can detect, but just routine servicing, where you're going to replace the oil every certain amount of time or wear. And then the predictive maintenance is the high tech. You're using stuff to look for condition. Where the preventive maintenance is looking for obvious things and maybe routine servicing to keep things from breaking. The predictive maintenance is seeking problems that you could not normally determine with your normal senses. Vibration analysis, that bearing, the pump looks fine, but the vibration signature says the inboard bearing on that pump has a problem. We need to work on that. Much more advanced notice than you might find a problem with preventive maintenance. The operators, they might be doing some of the maintenance. The hallmarks of operators doing maintenance is short duration, not using any special tools. It really depends on your culture and your technology, the culture of your people, the technology of your operation, whether you would do operators actually doing maintenance. One of the key industry leaders in that is Mike Galoff, Gehloff. It comes in different names. If you've heard of Total Productive Maintenance, that's operators. Total, everybody's involved in doing the maintenance. It's also called autonomous maintenance. The maintenance people are not involved, the operators are doing the maintenance. And if you hear operator care, that's I think what Mike Galoff calls it. That's a key thing too. All of these are generating work orders into the planning box. They're all generating work orders that the planners are going to get. Now, the engineers might also be generating projects. The projects could come into planning, but they could go directly to contractors a little bit outside of what we're dealing in. The maintenance strategy, just a few more things on RCM. It's a formal method. They're asking a series of questions. Is your asset like this? It is. Well, then you should do this kind of maintenance. Or it's not? We'll ask this question. Okay, well, is your asset like this? It is. Then do this kind of maintenance. It's not. Then ask this question. And simplistically, there's a series of 7 questions you go down, and it helps you determine what kind of maintenance you do. It helps you match your situation with the asset, and the failure mode might be obvious or not obvious. It might affect operation. It might not affect operation. So we're going through that to select our maintenance strategy, and of course, a key that we'll come back to is you need work orders to look at that. Next time, we'll look more at the planning cycle affecting the quality of execution and our productivity itself. So thanks for joining me. Thanks for letting me be part of your maintenance family today.